different types of charts available. Okay.
Okay, sir.
Charts basically your maps. Okay, how those maps are prepared, what are the things in that? Okay, chalo. Shasha, can you read?
Yes, sir. Chart projections general. The transfer of information from a globe onto a flat paper chart is achieved by projection because originally the technique involved using a light source within the globe to project the latitude or longitude graticule on a flat sheet of paper. Today, the projection is achieved mostly by using computer models. However, an understanding of the original projection techniques using light is more than adequate for understanding the properties of charts, whatever actual method of production is used.
Okay. So in olden days, how did they prepare the chart? Okay, they took a small globe, okay, on Earth. This they put a light source inside, okay, and they covered this with a flat sheet of paper like this. Okay. Now, when this light glue, we had this graticules. What is graticules? Network of meridians, anti-meridians, longitudes, and parallel of latitude. Okay. Yes, this light source will cast a shadow on this paper of this meridians, latitudes, etc. When the paper is cut open, you will have a projection of this latitudes, longitudes, etc. on the paper. Okay, this is how they made the chart in olden days. Today, computer is there. You just put the software and everything is ready-made. Mathematical model is there. But olden days, this is the way they did the chart. Okay. So this method is called projection method because it is based on a light source, projecting the graticule onto the piece of paper. Understood this?
Yes, sir.
Yes, sir.
Continue.
Perspective and non-perspective charts. Charts produced directly from a projection are called perspective or geometric projections. Charts produced by mathematical methods are called non-perspective charts. Most of the charts we use are in this letter.
So there are two types of chart. One is perspective, another is non-perspective. Perspective bole to kya? Perspective means you have taken a light source. Whatever lines are coming onto this, it is taken as it is. Such a chart is called perspective chart, or it is also called geometric chart. No changes in the meridians, latitude arrangements, nothing is done. Any chart which is based on mathematical methods, you do some kind of mathematical adjustment between meridians, latitude, longitudes, or you prepare everything mathematically, mathematical model, that is called non-perspective chart. Okay. Continue.
Okay.
Most of the charts we use are in this letter, non-perspective charts, non-perspective category, but they can be thought of as perspective projections which have been modified mathematically.
So in this chapter, whatever charts we are going to deal with are initially perspective. They are based on the light source. But later some mathematical adjustment is done. The moment you do some mathematical calculation in this chart to show areas correctly or to represent navigation function correctly, it becomes non-perspective chart. Okay?
Okay, sir. Okay.
Just note down on notes. I'll just give it to you. Yeah, take a note. Charts, then line, perspective, non-perspective. Perspective chart, charts produced by projection method is called perspective, bracket geometric. Non-perspective charts produced by mathematical methods. Write it down.
Done, sir.
Done, sir.
Done, sir.
Yeah, continue reading.
The reduced Earth. The term reduced Earth, RE, means the scale model of the Earth on which the projection of the chart is based. To make a 1:1 million chart scale model of the Earth will be used. Types of projection. There are three general types of projection surface: azimuthal or plane, cylindrical, and conical. Azimuthal or plane projection.
Reduced Earth means the whole Earth is taken and made into a small size as a representation, a scale model. Okay, you see those small globes kept in the showrooms or at the table. Okay, those are called reduced Earth. Okay,
Yes, sir.
Okay, sir.
continue.
Azimuthal or plane projections. An azimuthal projection is produced by placing a flat sheet of paper against a point on the Earth. A common use is to provide charts of the north-south polar regions, that is, the ULI example taught and examined in the JAA syllabus. The resulting polar stratigraphic charts Stereographic charts are covered in more details in a later chapter. The principle of this projection is to illustrate in figure 17.1.
What do you mean by azimuthal? If you are a person standing here and if you look horizontally like this, okay, that is called azimuthal. Okay, horizontally looking. Okay, so one type of projection is azimuthal, or you called it as plane projection. So let's talk about azimuthal. Now, I have a earth here. I have a light source kept on the top, a light bulb. Okay, now this light bulb will emit the lights in all the directions like this.
Yes.
Yes, sir.
Okay, अभी इसका जो graticule होगा, the graticule on this earth will fall onto this flat sheet of paper which is lying down.
Yeah.
Yes, sir.
Okay, such a projection method is called azimuthal projection. Now every projection has limitations. In this, the north pole won't be shown, only the south pole will come. Okay, that's a limitation of this projection. Okay, we'll see. So when you open this, okay, your chart will look like something like this. 180-degree east west is here, anti-meridian. Your prime meridian is here on the other side, 90-degree west, 90-degree east. Okay, and this will be the south pole which is represented over here. Okay, although this projection has produced a chart of entire southern hemisphere, the chart would only be used in the central area in case of flights over Antarctica. Okay, only certain areas of this charts will be used, not all the complete chart, because there will be certain limitations on this. Okay, we will go in depth. There is something called polar stereographic chart. We will go in depth about it when the chapter comes. After this, it will come. Okay, so this is azimuthal projection. So please write down azimuthal projection. Types of projection, write down. Azimuthal, plane, write down. Flat sheet of paper touches a point on the earth. Write down the first.
Done, sir.
Done, sir.
Done?
Done, sir.
Okay. Understood azimuthal projection? Azimuthal, or it's also called plane projection. Any question on this?
No, sir.
No, sir.
Okay. Now below this, draw a rough diagram of this. Earth and a flat sheet of paper and the light self bulb on top of it. Draw this diagram. Just a paper, earth, okay, right light source, reduced earth and flat paper. Okay. ताकि future में when you refer, it's easier for you to understand what is azimuthal projection.
Okay, sir.
Done?
Yes, sir.
Jaden and Gokul done?
Yes, sir.
Yes, sir, done.
Okay. Now Shasha, let's read about cylindrical projection.
Yeah, okay, sir.
1 second. Huh? Just hold on. Yeah, cylindrical. Then yeah, read cylindrical.
Cylindrical projections. The easiest chart projections were produced.
The earliest, not easiest, the earliest.
The earliest chart projections were produced in the 16th century by a Flemish navigator called Gerhard Remer, who used the Latin alias Mercator. His projections used cylinders of paper wrapped around the reduced Earth and touching the reduced Earth at the equator. The projection technique is illustrated in figure 17.3.
Okay. So we have the reduced Earth over here. This is the reduced Earth. Okay. And I place this pink sheet of paper wrapped around the Earth like this. Okay. मैंने पेपर लगा दिया ऐसे. ठीक है. Now I emit light source inside this. Okay. What will happen? The light source will go like this in all the directions.
Yes.
Okay.
Yes, sir.
Now I cut open this paper from here and I'll get a chart like this. This projection is called cylindrical projection. Now, where is the Earth touching the reduced Earth of paper? At the equator over here. This is the equator. Same, this equator line is represented over here also. Okay. But this chart has certain shortcomings. I'll explain it later. But this is what a cylindrical projection looks like. School time pe World Atlas map teacher used to show in the class. Have you ever seen? Geography teacher?
Yes, sir.
Yes, sir.
Yes, sir.
It is based on this projection. This guy created this chart in somewhere around 16th century and still we use it today. Okay. World Atlas map, which you see even today, is based on this projection, Mercator projection. Okay. Other details I will explain later, not now. Okay, continue.
When the graticule has been projected into the cylinder is open to produce a flat sheet of paper. Cartographers then can add the geographic detail. Note that the shape looks a little strange. This is explained in chapter 18. Again, notice that most of the world except the poles has been projected and the user would only use a section of the chart. Other charts that use cylindrical projection are the transverse Mercator and oblique Mercator. These also are explained in the later chapter.
So here, if you see, the equator is there, other latitudes are there, but latitudes are placed unevenly. Okay, why it happens, we will deal in chapter 18, which is the next chapter on Mercator. Understood this?
Yes, sir.
Yes, sir.
Okay. Now write down this cylinder, cylindrical projection. Second one, cylindrical projection. Cylinder touches reduced Earth at the equator.
Yeah, done, sir.
Okay. Asha and Gokul, please write down.
Yes. Done, sir.
Done,
Done?
sir.
Okay.
Yes, sir.
Draw this diagram, a rough diagram. Reduced Earth cylinder, and besides that, a flat sheet of paper. Show the meridians, graticules, and everything.
Okay, sir.
Okay. If you see the latitudes, 20 degrees, 40 degrees, 60 degrees, 70 degrees, the spacing is increasing. Same, northern may, southern may be 20 degrees, 40 degrees, 70 degrees, 60 degrees, 70 degrees, spacing is increasing. But longitudes are evenly spaced, equal. They are parallel to each other. Okay, draw that.